Hello everyone, welcome to the Berkeley channel. In this video we are going to talk about a problem from Berkeley Math Tournament from 2021. This problem came from the calculus type Berkeley. Here in this problem you have an infinite sum series. Here we have the sigma of negative 1 to the power of n minus 1 for the top of this fraction that you are seeing here. For the bottom we have n plus 1 choose 2. N is going to be between 1 and infinity, and we are going to find this infinite sum series now. Let's take a look at the original problem as described in the competition, and then we will see how to solve this problem. This is the original problem. As you see here, it's exactly the same way that we explained, and we are going to focus now on the solution. Now let's talk about the solution. The first thing that I'm going to use is to replace what I have for n plus 1 choose 2. I'm going to just replace it with the equation. I have n plus 1 choose 2 equals to n plus 1 times n over 2. Replacing it with this value, I'm going to move 2 to the top of this fraction. So I will end up with 2 times negative 1 to the power of n minus 1. For the bottom of this fraction, I still have n plus 1 and n. Now, remember, I have n plus 1 and n minus 1. But we know that negative 1 to the power of n minus 1 can be written in similar ways because at the end, negative 1 to the power of n minus 1 is going to be either 1 or negative 1. Starting from n equals to 1, negative 1 to the power of n minus 1 is going to be 1. So if I just want to use n and n minus 1, I will change the starting position, and instead of using 1, I'm going to start with 2. Then I will replace n plus 1 with n. I will replace n with n minus 1, and I will replace minus 1 to the power of n minus 1 with negative 1 to the power of n. The rest is easy. Now I have an infinite sum series. The point here is I have negative 1 to the power of n, and we know that it's going to be 1 if n is even and negative 1 if n is odd. So I'm going to replace this infinite sum series with two infinite sum series. The first one is going to represent all even numbers, and the second one is going to represent all odd numbers. Since the first one is for even numbers, negative 1 to the power of n is going to be just 1. On the other hand, for odd numbers, negative 1 to the power of n is going to be negative 1. The rest is easy. I'm going to just use 2k for n and 2k minus 1 for n minus 1 when n is even, and I'm going to use 2k plus 1 for n when n is odd, and then n minus 1 is going to be 2k. Combining these, you're going to see what I have at the end of this slide. Now I have the expression that you are seeing here. It is a telescoping series, so I'm going to divide it into what I get from a telescoping series. I think you can easily verify that, so let me skip that and move to the second part. Now the trick that I'm going to use is to first see what I'm dealing with. Let's focus on the first step. I have 1 over 2k minus 1 minus 1 over 2k. Starting from k equals to 1, I'm going to just use a few of the first terms. It's going to be 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 and so on and so forth. For the second one, I'm going to start with k equals to 1 again, but this time I'm going to have 1 over 2 for the first step. Then I will have negative 1 over 3 plus 1 over 4, negative 1 over 5 and so on and so forth. The thing that you are going to see here is basically, let's focus on the first one for now. The thing that you are going to see is I have 1 over n because I just have 1, 2, 3, 4, 5, and so on and so forth, and they are alternating. I have negative 1 to the power of something. Let's start with that. I'm going to replace the whole thing that I have here with negative 1 to the power of k minus 1 over k. Starting from k equals to 1, you're going to see that it actually gives me the exactly same infinite sum series. For the second one, I'm going to use the same trick, but this time I'm going to start with k equals to 2 because the first thing is 1 over 2. Now I'm going to combine these two. The problem is one of them starts from k equals to 1 and the other one starts from k equals to 2. So I'm going to compensate that with just reducing a negative 1 here. Now I need to evaluate the expression that I have. To do this, I'm going to refer to this alternating series. The Wikipedia that I have here, you can take a look. But basically, negative 1 to the power of n plus 1 over n times x to the power of n, and then getting an infinite sum series of these is going to end up with ln of 1 plus x. Using this infinite sum series, I'm going to replace the whole thing with 2 times ln of 1 plus 1 minus 1 as you see here, which results in 4 times ln 2 minus 2, and that's our final answer. Thanks for watching the video. Hope you enjoyed the content that I have in this video. If you want to see more puzzles, math-involved activities and problems from different math competitions, please subscribe to this channel. I hope to see you in the next video.